Let us to our 10th topic, which is called optimization of the basic block. Basic block and a flow graph. What is a basic block? Basic block is a sequence of constructive statement in which a flow of control enters at the beginning of leaves at the end of the block without any halt or possibility to a branch except at the end. The following sequence of three statements forms a basic block. Basic block B1. Basic B1 is a basic block. All these statements are combined one block, which is called one basic block. The basic block construction is algorithm parts into basic block, a sequence of three-headed statements. Output a list of basic blocks with each three-headed statement in exactly one method. First, determine set of headers. First statement of basic block. The rules we use for the following. The first statement is a leader. Any statement is to be target of the conditional or unconditional go-to is a leader. Any statement is immediately follows a go-to or unconditional go-to is a leader. For each leader is a basic block consists of the leader and all statements up but not including the next leader or end of the program. These are the basic block algorithm. These are three address code. There are 12 three address code statements are here. In this 12 three address code statement, the first two is one basic block. No, all these are independent statement. From the third onwards, we call them the basic block. Basic block 1, statement 1 and 2. Basic block 2, statement 3 to 12. These are all combined, interlinked. In between, no leaving the branch one place to other place. Okay. Entering at the beginning, leaving at the ending. This is called one basic block. Flow graph. The flow graph is a directed graph containing the flow of control from information or then set of basic block making up a program. The nodes of a flow graph are basic block. It has distinctly initial node. The B1 is the initial node, B2 is immediately follows the B1. So there is an edge from B1 to B2. The target jump from the last statement of the B1 to the first statement of the B2. So there is an edge from B1 to B2. B1 is preceded, B2 is the successor of the B1. Loop. The loop is a collection of nodes to flow graph such that all nodes in the collections are strongly connected. The collection of nodes has unique entry. Loop that contains no other loops is called as inner loop. So it is a basic block 1, it's basic block 2. So loop is going for only the basic block, not one block from another block. Optimization of the basic block. A number of transformations can be applied to a basic block without expressions completed by the block. Two important processes of the transformations are structure preserving transformations, algebraic transformation. Structure preserving transformations are the primarily structure preserving transformations on a basic block are common subjects for elimination, dead code elimination, remaining of temporary variables, renaming of temporary variables, interchange of two independent adjustment statements. These are called structure preserving. The common sub-expression elimination. Common sub-expression expressions are not be computed over and over again. Instead of they can be computed one kept in store for this that is referred. For example, this is a three-headed code. The second and fourth segments are computed same expression B plus C and A and D minus D. The base block can be transformed to B plus D is used only one time, then followed by second statement. This is called as a common subject for elimination. Dead code elimination. Once the variable is used, that variable is not wherever following further statement, you have never used that variable is called as a dead code. That code can be eliminated for the benefit of optimization. Renaming of temporary. Renaming and temporary use that rename can be used for the t equal b plus c, where the t is temporary name. We can use to rename that u equal b plus c. So the rename can be used for the temporary variables. Interchange them two independent adjustments. T1 equal b plus c, T2 equal x plus y, they can interchange without there is not any modification, any main change. Algebraic transformations. Algebraic transformations are for doing some multiplication of the 3 into 2.3.14 would be replaced by 6.38. So whatever the addition and subtraction multiplication, it simple means we can replace it. Call this also algebraic simplification. The relation operators less than equal, greater than equal, less than, greater than, plus equal something or 100 times with the expression. The associate law may also be applied for Expose common subjects. For example, A equal B plus C, E equal C plus D plus B. The following intermediate code may be generated. A equal B plus C, T equal C plus D, E equal T plus D. X equal to X plus 0 can be removed. X equal to X power 2 can be replaced by the cheaper operator X equal to X into Y. The compiler writer would examine the language specification carefully to determine what arrangements of the computations are permitted. Since computer architecture does not always obey the algebraic identification of the mathematics. DAG representation of the basic clock. DAG for a basic clock is a directed cyclic clock with the following labels or nodes. Leaves are labeled by unique identifier, either variable names or constant. Interior nodes are labeled by the operator. The nodes are also optionally given with a sequence of identifiers for the label to store the computed values. DAGs are useful data structure for implementing transformation in basic block. It gives a picture of how the value computed by a statement is used to subsequent statement. It provides a good way of determining common subexpressions. Algorithm for construction of DAG. Input to the basic block. DAG of the basic block contain the following information. A label for each node. For each a label is identified. Interior nodes are an operator example. For each node is a list of attached identifier to all the computed values. Consider the following three-headed statement. T equal to T1 equal to 4 T, T2 equal to E of T1, T3. This 10 statements are there. This is called three-headed statement. So this three-headed statement, how to construct a basic block. Okay. The following three-headed statement, S1 equal to 4 T. They construct here DAG for S1, 4 I. Similarly, S2 equal to E of S1, S2 equal to E of S1, E of S1. S1 value will be computed in S2. Followed by S3 equal to 4 time. S3 equal is S1, S2. S3 equal 4 time. Again, S4 equal B of S plus 3. S3, S4 equal to B of S3. S5 equal to S2 into S4. S2 into S4. S2 into S4 equal to S5. S6. Okay, product plus will be S6. S7 will be yeah, plus I plus 1 plus I is S7. The same value is I less than equal to 20, go for the last loop. So this is called as DAG. Thank you for listening this lesson.